This video is going to help you understand how to convert from grams to moles to molecules. Okay, the question is, what is the mass of 2.50 moles of oxygen gas used? So you first need to think about what kind of problem is this? Well, the given is moles, and they want you to convert to grams, moles to grams. So basically you're starting here and you're going to grams, moles to grams. Alright, so this is the same as a dimensional analysis that we used before. You write down the given first. Always write down the given. So we have 2.50 moles. And now you need to make sure you identify the substance. Oxygen gas. Now remember that's diatomic. So O2. O2. And we need to convert it to grams. Moles to grams. Okay, well, we use our dimensional analysis. If moles is on the top, it must go on the bottom of the next fraction. So moles of O2 have to go on the bottom. And we need grams of O2 at the top. Well, we need to first find the molar mass of O2. So go off to the side and find the molar mass of O2. So I have 2 atoms of oxygen, and each of them are 16.00. And so that is going to equal 32.00 grams. So I'm going to take that number right here and I'm going to plug it in up here by the grams. Alright, so let's do that. 32.00 grams. Okay, now it's a multiplication problem. 2.50 times 32 grams will give you 80 grams. 80.0 grams. Okay, let's review what we just did. We took the given, and the given was in moles. And we basically multiplied by the molar mass. We learned this week, that in order to find molar mass, that the units are grams, or grams per mole, and that you just look on the periodic table and you add up all of the mass of the atoms in your given formula. So our formula was O2, so we had to do 2 O's, 16 each, we had 32 grams. And then that made our conversion to grams. Let's look at this sample problem. A pain reliever tablet contains 33 grams of ibuprofen. The formula for that is C13H18O2. How many moles is this? So we need to think again what kind of problem this is. All right, this is a grams to moles problem. So you're going to begin with grams and you're going to go to moles. Grams to moles. All right, well, let's get to it. Always start with the given. 33 grams of C13H18O2. And you're going to be asked to change that to moles. Grams to moles. All right, we use our dimensional analysis. So if we have grams on top, we have to put grams on the bottom of the next fraction, and that would be grams of C13H18O2. And that will be how many grams are in 1 mole. Remember to always put 1 by mole, and that's that substance on top. So we need to get the grams. So what you will do is you will move over here to the side, and you will look at where I calculated down here. I took C13H18O2, so 13, 18, and 2. I multiplied by the masses from the periodic table and found the molar mass to be 206.31. So that number is going to go in this area right here. So 206.31. So we can see that it's a division problem. 33 divided by 206.31 will give us 0.16 moles. 0.16 moles. Alright, let's reflect and see what we did. So we took the given and we multiply it by 1 over the molar mass so that the grams would cancel out, and we changed our answer to moles. So that's the pattern that we're looking at. Now that we've did 2 examples, we're going to move on to the hot dog paper. So you might want to press pause in this video and get out your hot dog paper and your book. We're going to work on page 242. We're going to do numbers 1 through 3. 1 through 3. And this is probably going to take up a good portion of your paper. That's okay. You can write the homework underneath if it works out better. Alright, so on page 242, we're going to do number 1. And number 1 says, how many moles of compound are there in the following? And the given is 6.60 grams of NH4 parentheses 2 SO4. And they would like us to convert it to moles. Alright, so we're going from grams to moles. So that means that if grams is in the top, I have to put grams at the bottom. That would be grams of ammonium sulfate. That's how many grams are in 1 mole of ammonium sulfate. So I need the molar mass of ammonium sulfate. So I have to go over to the side and figure out that for N, there are 2 atoms of N. There are 8 atoms of H, 1 atom of S, and 4 atoms of O. And so now we have to look up their mass on the periodic table. And for nitrogen, we have 14.07. And for hydrogen, 1.01. And for sulfur, 32.07. And oxygen, okay, and 0.07. And oxygen is, I know this one, 16.00. Alright, so we're going to multiply these across. So this will be 28.14, 8.08, and 32.07. And this will be 64.00. Alright, now we need a total. And if you add all that up, I do it on my calculator. And I'm going to get 28.14 plus 8.08 plus 32.07 plus 64. And I get 132.29. So this comes out to be 132.29. And that's grams. So that's the number that I need to plug in up here. So I put in 132.29 grams. And now it becomes a division problem. So we have 6.6 divided by 132.29. And I get 0.05. So this answer is 0.05. 0.05. Alright, let's look at what we did here. So what did we do? We took the given and grams, given in grams, and we multiplied by 1 over the molar mass, so that grams will cancel out, and that converted us to moles. Alright, now we're going to do 1b. Now in 1b, they're trying to trick you, because they said to use as a given 4.5 kilograms. So the given was 4.5 kilograms. But we don't have anything that takes kilograms to moles to molecules. Remember that it's grams to moles to molecules, not kilograms. So we first have to take our kilograms and convert it to grams. Well, that's easy. All we have to do is move the decimal 3 places. So 3 places to the right, and that will give us 4,500 grams to begin with. That's our given. And the question is asking us to change it to moles. Alright, we can do this. We have grams on top. Oh, and it's grams of CaOH3. So you should write that in there. OH2. now we'll put our little railroad track in there. And so now we're going to divide by the molar mass. Oh, we have to figure the molar mass out. So let's see, for Ca, there's 1, 2 oxygens, 2 hydrogens. And we look up calcium, and calcium is 40.08. So 40.08, oxygen is 16, and hydrogen is 1.01. And so we multiply across 32 and 2.02, and now we add down, so we get 74.10 grams. So we know that goes on the bottom, 74.10 grams of CaOH2. And on the top, that's in 1 mole of CaOH2. Alright, so now it's a division problem. We take 4,500, and divide it by 74.10. And we get 60.73. 60.73. Alright, so that's our answer there. We can analyze what we did, reflect on what we did. We took the given and we times it by 1 over the molar mass. And that helped us convert to moles. Okay, I'm going to try one more with you. We're going to do number 2 on page 242. And this one is asking the question a little bit differently. It's asking you to take 25 grams, so this is our given, 25 grams of sulfuric acid, and they want you to change it to molecules. Grams, this is grams, to molecules. Alright, molecules. So remember that we can go grams to moles, and after we get to moles, then we can go to molecules. So that means we're going to need 2 more fractions to complete this. Alright, first step is, since we have grams here, we have grams right here, that means we have to put grams on the bottom over here. So the first thing that we need to do is to calculate the grams of sulfuric acid. So there are 2 H's, 1 S, 4 O's. Alright, so we're going to multiply across 2.02, 32.07, and 64.00. Add down 908, nope, 8 and 9, 98.09 grams for sulfuric acid. So that's the grams that goes down here, 98.09 grams. That would be grams of H2SO4. That's in 1 mole of H2SO4. So if moles are on top, so you see you have moles on top here, that means they have to go down here, moles. So we're going to put in 1 mole. We need to know how many molecules there are. Well, there was that secret number. That secret number given to us by Avogadro, and we figured out that, or now we, Avogadro, figured out that it was 6.022 times 10 to the 23rd molecules in every mole. And yes, we used that number before when we were speaking of atoms. 6.022 times 10 to the 23rd atoms in a mole. Well, that's how many molecules there are in a mole also. Alright, so now we have to work with our scientific notation. So we're going to take 25 times 6.022 times 10 to the 23rd. Remember to use that EE button. Use the EE button. And then press equals. And then divided by 98.09. And the answer that we'll get from that is going to be 1.53 times 10 to the 23rd molecules. Alright, so what did we do? We were given grams right here, and we went to moles by dividing by the molar mass, and then we converted to molecules by multiplying by Avogadro's number. We have worked through several practice problems. I would like you to finish 2B and number 3, and then go ahead and on the other side of the paper, go ahead and do page 253, number 31, and bring those to class on Monday.